Section 1.3, we're going to talk about the behavior of graphs as far as increasing, decreasing, or constant. Okay, so as I look at the graph I have here to the right, an interval that would be increasing would be one that I would see going up from the left to the right. Okay, so I have an interval of increasing here, an interval of increasing here. A decreasing interval would be one that would be going down to the right. So I have one interval where my graph is decreasing, and then a constant interval, of course, would be where that function just stays horizontal. As far as naming these intervals, it would be in interval notation, and we use the x values to describe these intervals. So this says the function is increasing on the interval. If I want to look at this first interval where I have increase, I want to pay attention to what the x values are. It's increasing from -2 to -1. If I look at the x value on that point. And for these, we always put parentheses because at -1, that's where my graph changes its behavior, so we don't put the bracket to include it. It's always a parenthesis. And then I'll look at the second interval of increasing. If I look at just the x value, it's from 3 to 5. Again, those are always in parentheses because we're looking at an interval notation. Where is the graph decreasing? Okay, again, I'm going to look at the x values. This is my decreasing interval. Begins at 1, and then it stops decreasing at 3. The function is constant on the interval. If I look at the x values where it's horizontal, that's from -1 to +1. Okay, also with your graphs, we have something that's called relative maximum and relative minimum. Now our graph here, this curve, it will continue to go down to the left and continue to rise to the right, but where I have this hill and this valley, these are what we call the relative maximum and relative minimum. Those points where I have a peak and then where I have a valley. Okay, so this says find the numbers at which f has a relative maximum. So again, I want to know where at which x value do I have a maximum. Okay, it occurs here, which that point would be the point 0, 1. So I would say that my relative maximum is 1, okay, but it occurs at x equals 0. Okay, and I believe on your homework problems, this is kind of the way you'll answer it. They'll want to know where does it occur. It occurs at the x value, but it is the y value. Okay, so here, find the numbers for which f has a relative minimum. It's the same thing. This is my relative minimum point. Okay, that point has the coordinate of 2, -3. So I say that the minimum is -2, but it occurs at x equal 2. Okay, so that's part of how it's stated in the homework. Okay, one other thing from section 1.3 that we're going to cover is even and odd functions. Okay, something that we will use and talk about throughout the course. This is your definition for an even function. We say that the function f is even if f at -x is equal to f of x for all values of the x in the domain of f. The function is an odd function if you evaluate f at -x and it equals the opposite of f of x. Okay, so here's your example. You're given a function. I'm going to determine whether it's even or odd by substituting in -x. When I plug in -x here, I would get -x squared plus 6. That would be positive x squared plus 6. So f at negative x equals the same function as f of x. When this occurs, it means that you have an even function. Okay, on part B, if I do the same thing, g at negative x, if I plug in a negative x, I get, this would still be a negative x cubed, so that would be negative 7x cubed, minus a negative x would be a positive x. So g at negative x equals negative 7x cubed plus x, which is the exact opposite of the original function. So if it's the exact opposite, it means that this is an odd function. Okay, on C, we have h at negative x. If I plug in a negative x here, it would be negative x to the 5th plus 1. So h at negative x would equal negative x to the 5th plus 1. This is not the same as the original, but it's also not the complete opposite because of this still being a positive 1. So this is an example of a function that is neither even nor odd. Okay, so this is one way you can tell whether or not a function is even or odd if you have the equation. The other way is by looking at the graph. Okay, if you look at the last box, it says even functions. The graph of an even function is symmetric with respect to the y-axis. Okay, so an example of that would be a parabola. Okay, if we drew that exactly, this function would be symmetric about the y-axis, so this is an even function. Odd functions are symmetric with respect to the origin. Okay, an example of that would be if I have, let's say, a graph that has a point of 1, 2, and we'll say 0, 0, then also has a value of negative 1, negative 2. It may curve. If it has the same distance from the origin or symmetric about the origin, we say that it's an odd function.